So here we are looking at finding angles with trigonometric ratios. We went over this in class one time, but we're just to quickly go over it again. The right triangle is what we'll always be working with. There's always going to be an angle involved. Pythagorean theorem doesn't have any angles involved. This one does have angles involved. Wherever your angle is denotes where the opposite and adjacent sides of the triangle are. The hypotenuse is always across from the right angle, but the opposite and adjacent sides will switch depending on what angle you're working with. So the adjacent side is the one that's touching the angle, and the one across from the angle is the opposite side. The formulas are sine theta, cos theta, and tan theta. Opposite over hypotenuse for sine, adjacent over hypotenuse for cos, and an opposite over adjacent for tangent. So working with this example here, we have a triangle that has an angle here, a side of 8 and a side of 10. This side here would be the hypotenuse because it's across from the right angle. This side's touching the angle, so it's the adjacent. And this side here is the opposite because it's across from the angle. So seeing as how we're working with O and A, that would be the tangent formula. So we have tan theta equals opposite over adjacent. And filling in what we know, theta would be the x, the opposite side is 8, and the adjacent side here is 10. If I divide those out, I will get 0.8. And then I pull up my table with sine, cos, and tan. And under the tangent column, I'll go down. I'll find the closest number to 0.8. And in this case here, it works out to about 39 degrees. That is the angle. Let's take a look at another example. So again, we have a different position on the triangle here with the x down here now. The 14 would be the hypotenuse. It's across from the right angle. And here, the 9 is not touching the angle, so it's the opposite side. Opposite and hypotenuse are going to require the sine formula. So we have sine theta equals opposite over hypotenuse. In this case, sine x equals 9 over 14. And when we divide 9 by 14, we'll get approximately 0.6429. And now, under the sine column on my worksheet, I'll find the closest number to 0.6429. In this case, the closest number is going to be about matching up with 40 degrees.